Hello students, welcome back. Today we will study a question related to conditional probability. So let's first read the question. A particular web server may be working or not. If the server is not working, any attempt to access it fails. Even if the web server is working, an attempt to access it can fail due to network congestion beyond the control of web server. Suppose that a priori probability that the server is working is zero point 0.8. So this we have given that. Let us consider an event A as server is working as event A, and we have been given that probability of A is zero point 0.8. Now suppose that if server is working, then each access attempt is successful with probability zero point 0.9. Access attempt successful, take it as event B. But we have given with the condition if the server is working. So basically what we have given as zero point 0.9 is B given server is working, that is A is zero point 0.9. Okay? Independently of other access attempts. Now find the following quantities. Probability of first access attempt fails. We have to find when first access attempt can be failed. First, when server is not working, second, and second when server is working but our attempt has failed. So how will it be done? First, what we have given is these two. From here we can calculate probability of server not working, which is 1 minus probability of A, which is 0.2, and then probability of access attempt failing given a server is working. So 1 minus probability of B given A, which is 0.1. Now we also know that if server is not working on, then an attempt will definitely fail. So probability that attempt fails given server is not working is 1. Now we want this first one. Let it be F1. Probability of F1 first attempt fails is probability of server attempt failing. Attempt failing can be done like this also, but chalo, F1 is okay. Attempt failing given server is working into probability of A plus probability of failing server is not working and probability of server not working. In this I have used total law of not total law of probability, multiplication theorem, which is in the probability. Here F1 is same as B complement because we are in first attempt only. First access attempt fails is equal to B complement that our attempt has failed. B's access attempt is successful. So now just put in the values that B complement A is when server is working but our attempt fails is 0.1. Probability of server working is 0.8 plus that is 1. Server not working is 2, which is 0.08 plus 0.2, which is 0.2. This is our required probability of answer 1. Now second what we have to find is probability that server is working given that first access attempt fails. Alright, so how will we do this? Server is working is our A, first attempt access attempt fails is F1. Alright, or you can also say B complement. So probability of A given F1, there is a formula also which is probability of A intersection F1, conditional probability formula, probability of F1 Probability of A intersection F1 can also be written as probability of F1 given A into probability of A. It's just this formula only which I have rearranged the terms because we have this formula. Probability of F1 we know 0.28. F1 is same as B complement, alright. So probability of B complement given A is this 0.1. So I will just put in the value which is 0.1 and probability of A is 0.8 divided by 0.28. It is 4 से cancel करेंगे 2 by 7 is our probability that server is working given our first attempt fails. Now second access attempt fails given first access attempt fails. So let it be F2 and F1. Probability of F2 given F1 is probability of F1 intersection F2 over probability of F1. Probability of F1 we know, but we have to calculate this probability. So now how we are going to calculate it? We'll calculate it by probability that first and second access attempt fails. Okay, is probability that F1 intersection F2 given server is working and probability of server is working plus probability that first and second attempt fails given server is not working and then probability of server. Alright, so now what we will do, probability that both the attempts have failed given server is working would be like, since they are independent, we are given in the question, independent of the other access attempts. So we will write it as probability that first access attempt fails given server is working, probability second access attempt fails given server is working into probability of A plus probability of first access attempt. In this case, since server is not working, you can write it like this also, probability of F2 server is not working, probability of server not working. Right, since we are given that F1 and F2 are independent events. So now this is F1 is same as our B complement that any access attempt fails given server is working is 0.1 into 0.1 into 0.8 probability of A. This is 1 because if server is not working then we are sure that any access attempt will fail into 1 into 0.2. So now it is 0.208. This is our answer for the third part of this. So we have done this, this and this. Now fourth part is probability that server is working given first, one second. In third part I've just calculated probability of F1 intersection F2. I want to calculate this whole, so it would be 0.208 and probability F1 we have calculated just above, which is 0.28, and on simplifying we will get 26 by 35. Yeah. So now fourth one is server is working is A. First and second attempt fails is F1 intersection F2. And you know why I have done this, because the results of two consecutive attempts to access the web server are conditionally independent events. Hence, I have written them like this. I have explained it also that it is here written in this line. That's why we have used it. Now probability of A given F1 intersection F2 is probability of A intersection F1 intersection F2, or probability of F1 intersection F2, which can also be written as probability of F1 intersection F2 given A into probability of A, and this probability I have just calculated, that is 0.208. Now this one, that first and second access attempt fails, though we have given that server is working, we have calculated it here. Here, which is this, which is 0.1 into 0.1 into 0.1. Probability of A is 0.8, and this we know is 0.208, which is 8 by 208, which in turn implies 1 by 26. 8 to the 16, then 48, 6. This is the answer to the fourth part. That's all for today. Thank you, everyone.